Good morning, Math 10s. So we're moving on to lesson 9 of your student workbook on page 471. This is going to be our last lesson on function notation. The good thing about this lesson is, for the most part, it's going to be a review of lesson 8. I'm going to introduce graphing though. So just to do a quick review of lesson 8, up to this point, you are used to dealing with something called function notation. So function notation, for example, sorry, not function notation, you're used to dealing with XY notation. So XY notation would be giving you an equation written using the variables x and y. So x is equal to, for example, 3x plus 5. And then from here, if I was to say to you, okay, well, if x is equal to 4, what's the corresponding y value? So you would say, okay, well, y is equal to 3 times 4 plus 5. Y is equal to 12 plus 5, and the corresponding y value would be 17. So as an ordered pair, the x value would be 4, and the corresponding y value would be 17. In lesson 8, I said that generally we don't write it in XY notation. We would rewrite this in what is called function notation. And mathematicians just much prefer function notation. And in Math 30-1, the entire course is done in function notation. So function notation, we simply take out this y and we replace it with f of x. And then we would say f of x is equal to 3x plus 5. So this just tells me f of x that we're dealing with a function. And remember, all functions pass a vertical line test. And all functions are also relations. So from here, I could say, well, what is f of 5? And so that's just telling you that they want your x value to be 5. So wherever we see an x value, I'm going to put a 5 in a bracket, and I'm going to evaluate what my corresponding y value would be. So f at 5 would be 3 times 5 plus 5. And 3 times 5 is 15. 15 plus 5 is 20. So f at 5 is equal to 20. So that would be my answer in function notation. And when x is 5, y is 20. So it's the exact same thing as writing XY notation, except we're dealing with function notation. Let's look at class example number 1, which is going to be dealing with graphing. So it says, use a graphing calculator to sketch the graph of the following function. F of x is equal to 3x plus 1. So I'm going to write that down. F of x is equal to 3x plus 1. I know that f of x, to write this in xy notation, would be y is equal to 3x plus 1. And then if I was to graph this, so on your calculators, you would go to y is equal to, and type in what function they want. So the function that they want us to graph is 3x plus 1. Here's my graph. If your window looks slightly different than this, this is what our default window is, and it's a 10 by 10 window. So the x value goes up to 10 here, the y value goes up to 10. So if your window looks different, you always could just hit zoom 6, would send you back to the 10 by 10 window. Now we should, in order to do a nice graph, we should plot some values. So remember that there's a couple different ways that we could plot some values. So I could go to second function table, and I could get some values. So for example, when x is -2, y is -5, right? I'm going to write that ordered pair down. When x is -2, y is -5. And another value, when x is 0, y is 1. When x is 0, y is 1. A third value, when x is 1, y is 4. So I'm going to plot those. So when x is -2, y is -5. And when x is 0, y is 1. And when x is 1, y is 4. Okay? So in order to get a nice graph, you need at least a few values. Okay, so that's not working, that's fine. You would take a ruler and you would graph this, and that would be our corresponding graph there. Now remember, I didn't have to look at my table of values. I could have plugged in by hand f of negative 2, right? So I could have said, okay, well, what is f of negative 2? So whenever I see an x, I'm going to plug in a negative 2. So 3 times negative 2 plus 1. F of negative 2 is negative 6 plus 1. F at negative 2, negative 6 plus 1 is negative 5, right? Which is exactly what I have there. And then I could have plugged in f of 0, and I would have gotten 1. I could have plugged in f of 1, and I would have gotten 4. But that's your example to class example number 1. For class example number 2, it says, in each case, express the relation in function notation as an equation in 2 variables. Okay, so what they've given me is this is in function notation. If you see f with a bracket or g with a bracket, this is function notation. And what they want me to do is they want me to express this in 2 variables. Right now it's only expressed in 1 variable, and that's the variable x. Well, 2 variables, that's what you're used to. You're used to x and y, right? So if I was to rewrite this in 2 variables, how would I do that? F of x is the same thing as y, and then I just write exactly what I have on the right-hand side. 7x minus 23. So that's my xy notation in 2 variables. This is function notation. So they just said, please just take, it's already written in function notation, write it in xy notation. So again, this one here, g of t is equal to this. Write this in 2 variables. G of t is just a fancy way of saying y. T squared minus 2t plus 35. There's my answer in 2 variables. And my 2 variables now are y and t. Okay, B says express the relation y is equal to 11x minus 15. Express that in function notation. So function notation, take out the y, and that becomes f of x is 11x minus 15. So another thing we're doing in this lesson is writing from xy notation to function notation. And if I give you a function notation, can you write in xy notation? That would be my answer for B. C, the graph of the function defined by y is equal to f of x has this equation here. So this is in xy notation. So they want this written in function notation. F of x is equal to 4 minus 3x, and now you are in function notation. Flip your page to class example 3. So this is the last class example, and then I'll set you up with the homework and I'll help you with a couple homework questions. So class example 3 is going to be a graph. So this is really important. Can you read a graph if it's written in function notation? So here is where my x values go. And instead of writing y, they wrote f of x. So why did we do that? Because you know that y is equal to whatever the equation is, y can now be replaced with f of x. So yes, this is where y goes. That's my y-axis. But now you know that y is the same thing as saying f of x. So I just wanted to explain that to you. They want f of 5. So you have to ask yourself, what was this? F of 5, was that x or was that y, right? If it's in the bracket, that is x. So what they're saying is, what is the corresponding y value on my graph when x is equal to 5? So go and find where x is 5. Here's where x is 5. What's the corresponding y value? So when x is 5, that corresponding y value is -2. So f of 5 is equal to -2. I'll do the next one, and then I want you guys to do the third one. So if I go to the next one, f at -2. So they're saying it's in the bracket when x is -2. What's the corresponding y value? So here is -2. Find where that coordinate is on your graph. So on your graph, that coordinate is right here. So when x is -2, what's the corresponding y value? The answer is 3. See if you could do this third one. Pause this and see if you could figure out f of 4 when x is equal to 4. Okay, on my graph, there's 4. So 4 comma, when x is 4, my y value would be -1. So that answer is -1. Write the ordered pairs associated from 1, 2, and 3, and I actually have the ordered pairs already written. So my ordered pairs would be the first one when x is 5, y is -2. Second one when x is -2, y is 3. Third ordered pair when x is 4, y is -1. Okay? Now for C, so I'm just going to erase this. What they're telling me to do for C, remember I always say to yourself, what have they given you here? This -1, is that the x value or the y value? They gave us the output. They've given me the y value, right? You have to see that that's my y value. And they want to know when y is -1, so when y is equal to -1, what does x equal to, right? They want to know, well, what is this? So I need to go, this is my y-axis, and when y is -1, there's -1. The point on my graph would be right here. When y is -1, what's the corresponding x value? And that corresponding x value is 4. So I could either say x is equal to 4 or f of 4 is equal to -1. But x is equal to 4 is the answer. Okay, let's look at f of x is 3. So what they're saying here, because it's on the right-hand side, they're saying when y is equal to 3. So 1, 2, 3. Now, this is an interesting question. I like this one. If I said to you, okay, go to your graph, and where's y is equal to 3? So what do you guys think? Where's y equal to 3? Well, here's a coordinate where y is 3, x comma 3. But do you also see that this would be an answer too? X comma 3. Both of these, this one would actually have two different answers, right? And this x value is 2. So one of my answers is 2. And this x value is -2. So when y is 3 on this particular graph, I have two solutions. I have x is 2 and x is -2 when my y value is 3. Okay, I'm just going to erase this and let's figure out when y is 4. So that's my y value when y is 4. Here's 4, right? 1, 2, 3, 4. So what are the corresponding x values? There's a solution there, and there's a solution there. So my x values when y is 4 is plus or minus 1, right? This solution, that ordered pair would be 1, comma 4, and this ordered pair would be -1, comma 4. D says use the notation in A, so function notation, to make a statement about points A and points B on the graph. So let's write points A and points B. So first of all, let's figure out what these ordered pairs are. So that would be -5, comma 1, and b would be 6, what's that y value? -3. Okay, how would I write this in function notation? So function notation is going to be, so let's do A first, and I'll do A in pink. Normally we write f of x is equal to whatever the y value is. Well, they want x to be -5. So f of -5 is equal to, when x is -5, what's the corresponding y value? It's 1. That would be point A. Point B, let's do it in blue. F of, we always put our x value in the bracket. So when x is 6, what was the corresponding y value at this point here? And the corresponding y value is -3. So f at 6 is equal to -3. E, write the x and y intercepts of the graph using function notation. Okay, so let's do E, x and y intercepts. So let's deal with the x-intercepts first. Remember, the x-intercepts are, what letter would equal 0 for x-intercepts when y is equal to 0? So on your graph, if this is your x-axis, where does your graph cut or touch the x-axis? So here, and that point would be -3, 0. And even though it doesn't actually cut it, it touches the x-axis there, and that point is at -6, 0. So remember, for x-intercepts, y is always equal to 0. So if I said, okay, we'll write these two ordered pairs or these two coordinates in function notation, simple. This ordered pair in function notation would be f of -6 is equal to 0. And this guy, that's my x value. So it would be f of -3 is equal to 0. That would be my x-intercepts. My y-intercept on this graph is when x is equal to 0. So if I go to my graph, here's my y-axis, so I'll just write that in here. Where the graph cuts the y-intercept is right there. That ordered pair, x is 0 there, right? X is 0, y is 5. How would you write the coordinate or the ordered pair 0, 5 in function notation? F of 0 is equal to 5, and you'd be done. Last question. This is a really good review because it's a domain and range question. So it's a good review of lesson 4, which was on domain and range. So remember that domain are your x values. So look at your graph, and what is your biggest and your smallest x value on this graph? So my smallest x value is -6, and my biggest x value is 7. And then remember, when we're writing our domain, we put x in the center when we have a biggest and a smallest number. And we would write the biggest number on the right and the smallest number on the left. And how I would read my domain is x is less than or equal to 7, greater than or equal to -6. And then I would say comma XER. So writing that for my domain, look at this. They already have my fancy bracket. X is such that my biggest x goes on the right and my smallest x goes on the left. And that's my domain. My range is my y values. So look at this graph, pause this, see if you could find the biggest and the smallest y value. Biggest y value is 5. Smallest y value is -4. Now, the range is kind of interesting because we're doing function notation. Normally, I would say you put y in the center and you put your biggest on the right and your smallest on the left, right? So normally it would be the biggest number is 5 and the smallest number is -4. That's what we would normally do, comma y-e-r. However, for range, those of you that are really understanding this, I would say in class, okay, well, what is y the same thing as writing? Like if I said write this in function notation, what's another way of stating y? So y could be written, we could take y out and we could put f of x in. Because remember, every time you see an f of x, that's just a fancy way of writing y. So this is how we could write our range. And you don't need to write your range using f of x in grade 10, but in Math 20-1 and 30-1, students who write their range and have f of x here, they have sort of an even better understanding than students who write y. Okay, so my range, the biggest y value is 5, and the smallest y value is -4. Look at what your book did. That's just a fancy way of saying y. And then, ooh la la, they did it here too. Instead of saying y-e-r, they actually did complete function notation. So they took out the y and they put in f of x. And they said f of x belongs to the set of real numbers. And again, what does that mean? Well, all that means is I could pick any point on my graph, so like this point here, and that point could be a decimal. So that point might be 1, 2, 3.2, right? So that's what x belongs or y belongs to the set of real numbers is. Okay, here's your homework. 1, 2, number 3, 4, 5a, it starts, so we'll do it together. 6, 7a, and 12. So I believe I have everything circled for you. Number 1, in each case, express the relation that's given in function notation, express it in two variables. That means do x, y notation. So I'll do the first one for you. Y is equal to 10 minus 3x. I've converted from function notation into xy notation. For number 2, it's in two variables and they want it in function notation. So A is easy. So you guys do A, right? Or I'll do it with you, I guess. Y is just saying f of x is equal to 17x minus 9. Now, B, it's a little tricky. Normally, I would say, yes, y is the same thing as f of x, but what letter do they want me to have instead of x? And I just scan what letter they have on the right-hand side. Instead of saying f of x, they actually more correct would be for me to say f of v is equal to 4v plus 25. Because now, if I say, well, what is f of 3? Every time I see a v, I'm going to put in a 3, right? So that would be your answer for B. So we just did number 2 together. Number 3, express this in function notation, right? So easy, take out that y, put in f of x. This one, express this equation, it's in two variables, in function notation. So again, f of, now what they want here is I always look at this side, I look at the right-hand side, and they want t. So f of t is 4.9 t squared. That's how you would do B, okay? This guy would just be f of x because they've got an x here. 0.5 x minus 0.25. Number 4, this is exactly like we did in that last class example. So I want you to take your time with this. And if you need to, you look at my last class example, right? So remember that f of 3 when x is equal to 3. So here's x is 3. When x is equal to 3, what's my corresponding y value? that y value is -1, right? So I want you to try number 4. Number 5, the function g of x is given by this equation here, and it has this domain. How would you do A? A says state the range. Okay, domain. Domain are my x values. So x is -2, x is -1, x is 0, x is 1, x is 2. What are the corresponding y values, or the range, when we're given these x values? So how you would do this is g of x is equal to 3x squared minus 4. G of, let's put in our first x value, -2. 3 times -2 squared minus 4. What is g of -2? So -2 squared is 4. 4 times 3 is 8. Nope. 4 times 3 is 12. And 12 minus 4 is 8. So if you plug in -2, you should get a y value of 8. Then they want you to plug in -1. G of -1. 3 times -1 squared minus 4. -1 squared is 1, times 3 is 3. 3 minus 4 is -1. So my range is -1. Then they want you to type in 0. Input 0. 3 times 0 squared minus 4. Anything times 0 is 0, so I get -4. That's my range. And then remember, you guys, you will calculate 1 for me and calculate 2 for me. And when we do the range, the y values, goes in a fancy bracket, and you list it from the smallest y value to the biggest. So I put that -4 first, that -1. Depending on what the other two answers are, 8 would go next, but you need to finish off the range for me. Okay. Number 6, another good example. However, before you do number 6, you have to do the scale. So 1 hatch mark does not represent 1. So remember, count up how they got to here. So 1, 2, 3, 4, 5. 10 divided by 5 is 2. So the scale is 2. Each hatch mark represents 2. So if I erase this and I put in, that would be 2, 4, 6, 8, and 10, right? And what they're saying, okay, when x is -6, when x is -6, what's the corresponding y value? Remember, f of x is a fancy way of saying y. So when x is -6, -2, -4, -6, what's that y value? One hatch mark down is -2. So -6, -2, because remember our scale is 2. It goes up or down, left or right. Each hatch mark is 2. This, what they're telling you, an ordered pair is x comma y. So that's my x value. When x is 2, what's the corresponding y value? So when x is 2, y is 2, 4, that would be 6, right? What this one is saying is when y is 0, okay? So what they're saying is when y is 0. This guy is saying when y is -6. When y is -6, -2, 4, 6, that x value is 8. Nope, -8. And here, when y is 0, right there, what's that x value? So when y is 0, x is also 0. Okay, so Try to do that one completely on your own if you're able to. For 7, I want you to do A. You're just inputting -3. When x is -3, what's the corresponding y value? And then the last question is 12. The value of A when y is 0, right? So what is A when y is equal to 0? Now remember, y is saying f of x. A fancy way of writing y is f of x. So when f of x is equal to 0, so take this out and put 0 in there. And then manipulate this to solve for x. So add 11 to both sides and then divide by 5 and you'll get your answer.